Electrical safety. In this lesson, we're talking about why we should know about electricity, what can happen when you're dealing with electricity, electrical boxes and circuit breakers, fuses, grounding and static discharge, wall outlets, GFCIs, dangling electrical lines, and safety tips. Why should we know about electrical safety? The available electrical current in regular businesses and homes has enough power to cause death by electrocution. Many people work with electricity at work and in their homes without knowing the dangers. And the dangers are significant. There are 30,000 non-fatal accidents each year at home. On average, there are 325 electrocutions each year. 2,555 are the number of children that are treated each year due to wall outlet shock accidents. Customer appliances cause 60 electrocutions each year, and electrical hazards cause more than 300 deaths and 4,000 injuries each year among the U.S. workforce. And lastly, electrocution is 6th among causes of workplace deaths in America. So what can happen? When electrical current travels through our bodies, it can interfere with the normal electrical signals between the brain and the muscles. So for example, your heart might stop beating, your breathing may stop, or your muscles may spasm. That means contract uncontrollably. Electricity can cause 4th-degree burns, charring the skin, and it can also be fatal. You can get burned if electricity arcs or heats up nearby objects. And shock burns can burn internal tissues while leaving outside skin with only mild injuries. So you can be shocked on the inside without having many visible signs on the outside. What can happen? An arc flash can also cause damage to the eyes as ultraviolet and infrared light is emitted. Electrical fires can also occur when appliances or cords catch fire. And this can happen when too many things are plugged into a single outlet, or for instance, if you plug a second power bar into a first power bar, thereby splitting the power even further. Each one of these things, each one of these cords requires a certain amount of power. So when you're overloading the circuit by plugging too many things at the same time, it can cause the wires to overheat and potentially catch fire. Electrical boxes and circuit breakers. All buildings have distribution panels made up of circuit breakers or fuses to control the flow of electricity. Each circuit in your house or apartment runs through a circuit breaker. So if you're in a house, generally these circuit breakers are going to be found in the basement, and if you live in an apartment, they're going to be generally found in a closet. But every unit should have one of these circuit breakers. If too much electricity is flowing, the system shuts down to prevent damage or possibly a fire. They shut off or trip if too much electricity is flowing. They can easily be reset, however, by flipping them like a switch. So if this switch gets flipped, let's just say they should all be facing this way, and it gets flipped that way because that circuit flips, because that circuit trips, all you need to do is go over to this switch right here and flip it back in this direction, and that circuit will be powered back on again. It's just like turning off and on a light switch. So here's a circuit breaker at my house, and you can see this one here had tripped. So all I would need to do is go down and flick it back the other way. Now these will trip if too much electricity is flowing through this particular circuit. So this is circuit number 11. So maybe on circuit number 11, I have my stove, microwave, and kettle. Now if all three of those things are going at the same time, that would pull too much power through the circuit breaker. If too much electricity is going through the circuit breaker, it's going to identify this and shut this breaker off to prevent a potential electrical fire. Fuses. Fuses are like circuit breakers and are typically used in older homes and some vehicles. If too much electricity is running through them, a part inside melts immediately, shutting down the flow of electricity. Once they melt, they need to be replaced. So on the inside, you have a thicker wire that goes in, and that funnels down into a thin wire that goes through, and then a thicker wire again leaves. This thin wire will melt if the temperature gets too high. Now the temperature will get too high if too much electricity is flowing through, and it will melt at a specific temperature. So if too much electricity is flowing through, this will get too hot, and if it gets too hot, it's going to sever, and if it severs, then no more electricity can get past. Grounding and static discharge. Electrical grounding is a means of moving excess electrons into the ground and away from you. Excess electrons can sometimes build up on electrical boxes and on machines and can be dangerous. The third plug on a typical electrical outlet is the ground. That's the third plug right there. It takes the excess electrical buildup and sends it into the ground. Grounding works because the earth, the ground, has so many electrons that no matter how many more are added or taken away, it just doesn't make a difference. So all the third outlets in your home are going to all funnel into your distribution panel, and then from the distribution panel, they're all going to funnel out into this wire right here in this example. This example runs outside the house and attaches to this water pipe, which goes into the ground. So any excess electrons end up on this metal pipe, which then goes into the ground, removing the electrons from the pipe. Wall outlets, otherwise known as receptacles. This is where we obtain our electricity for things like televisions, lamps, etc. Safety features on wall outlets include the fact that they're made of plastic generally. Plastic doesn't conduct electricity as well, so that's a safety feature. Number 2 is that they have polarized plugs. So one slot, you can see this guy here is bigger than this guy here. This forces you to insert the plug the correct way. And number 3 is most have a third ground hole, and we've already talked about that. That brings the excess electrons away from the outlet to a safer area. GFCIs. So you would have seen one of these at some point in your life. Generally, they're found near water areas, could be outside, bathroom, kitchen, and they're going to look like this. Now, GFCI stands for Ground Fault Circuit Interrupter. It's sometimes called an RDC, which is also called a residual current device. Generally in Europe, you're going to hear that name. A GFCI monitors the amount of current flowing within the outlet. If the current is being disrupted, like if you're being electrocuted, it shuts down the power in 1/30th of a second. So it's really fast, and it acts like a mini circuit breaker. A ground fault circuit interrupter compares the current leaving with the current that came back in. In a proper circuit, the current out should equal the current in. If electrical current is lost, so a maximum of 6 milliamps, so that's not too much, the GFCI trips. This turns electricity off before severe injuries or electrocution can occur. Once a GFCI has been tripped, it must be reset by pushing the reset button, and that's that red right there. So if you're ever using an outlet like this and it doesn't work, try hitting the reset button because it might have been tripped. And again, it's very similar to a circuit breaker that needs to be flipped after being tripped. An example of using the GFCI is if you're using an appliance near a water source. If the water supply comes in contact with the current, either because the appliance falls into the water, there's a break in the cord, etc., electricity will flow into the water and possibly electrocute you. The current will go into you and the water instead of going back into the outlet, so there'll be a loss. The GFCI will recognize this difference and will cut the flow of electricity immediately. This can still result in a painful but non-fatal shock during the time it takes for the GFCI to cut the electricity. So if you have, let's say, 3 amps coming in and only 2.9 amps going back towards the outlet, the GFCI outlet is going to recognize that the current out was not equal to the current in. The GFCI is going to shut down the current before it can cause electrocution. Dangling electrical lines. Electrical lines can be damaged by storms or accidents. If you see a downed electrical line, stay at least 10 meters or 32 feet away. If the electrical line lands on your car, stay in your car and call 911. The car will protect you. The car is going to act as what's called a Faraday cage. A Faraday cage is a metal cage that goes around you. So if you are inside the metal cage, and as long as you're not touching any of the metal parts, and generally on the inside of a car, it's going to be all plastic and glass, you'll be protected because the electricity will hit the car and stay on the outside of the car. It won't actually go into the inside of the car. It wants to stay on the metal. So if you are inside the car, that's going to be the safest place for you to be. So if you see a downed electrical line and it's anywhere near your car or it's on your car, stay in your car. Other safety tips when working with electricity. Whenever you're working on electricity, make sure the power is off at the breaker. If you're not sure which breaker corresponds to which outlet, there is a master switch on every circuit breaker that will turn them all off. Inspect portable cord and plug connected equipment, extension cords, power bars, and electrical fittings for damage or wear before each use. Ensure the GFCIs are installed in wet or damp areas as the risk of electric shock is greater there. Do not touch a person or electrical apparatus in the event of an electrical accident. And do not plug high amperage equipment such as space heaters, portable air conditioners, power saws, stuff like that, into extension cords. They should be on their own circuit. Now, this certainly doesn't exhaust the safety tips that are available, but if you're smart and you deal with electricity properly, you can stay safe while doing so. However, if you're not sure what to do, the best thing to do is always call a certified electrician. They know what to do, and they'll make sure everything is done properly and safely. And that concludes our lesson on electrical safety.